Hello students, we will discuss today your second chapter polynomials. First recall in class 9th you have studied degree of polynomial. What do you mean degree of polynomial? If px is a polynomial x, then the highest power of x in that polynomial is called the degree of the polynomial px. For example, let the polynomial be p 4x plus 2, then what is the variable x? Their highest power is 1, hence this polynomial has degree 1. Similarly, 2y square minus 3y plus 4 is a polynomial in the variable y of degree 2. The highest power of y is 2. Similarly, 5x cube minus 4x square plus x minus 2, this is also a polynomial in variable x with degree 3. Why? Because the highest power of variable is 3. Now, you know the expression like 1 upon x minus 1, under root x plus 2, 1 upon x square plus 2x plus 3, these type of polynomial, these type of expressions are not polynomial. The polynomial where the power of variables is always non-negative. Okay. Now, based on the degree of polynomial, these polynomials are known as linear, quadratic or cubic. For example, a polynomial of a degree 1 is called a linear polynomial, 2x minus 3 under root 3x plus 5. A polynomial of degree 2 is called a quadratic polynomial, such as 2x square plus 3x minus 2 by 5. Now, general form of a quadratic polynomial is ax square plus bx plus c, where a, b, c are real numbers and a is not equal to 0. A polynomial of degree 3 is called cubic polynomial. Some examples are 2 minus x cube, and general form of a cubic polynomial is ax cube plus bx plus ax cube plus bx square plus cx plus d, where a, b, c, d are real numbers and the coefficient of x cube is not equal to 0. Okay. Now, value of a polynomial in at any real number. This you have already studied in your previous class, that means in class 9th. If px is a polynomial in x and if k is any real number, then the value obtained by replacing x by k in px is called the value of px at x equal to k, and it is denoted by pk. Okay. For example, if px is equal to x square minus 3x minus 4, then if we put x equal to 2 in our polynomial, what we get? p2, 2 to the power 2 minus 3 into 2 minus 4 is equal to minus 6. This minus 6 is called the value of polynomial px at x equal to 2. Next definition, 0 of a polynomial. A real number k is said to be 0 of a polynomial px if p of k is equal to 0. That means any number for which the value of polynomial is 0, then that number is called 0 of that polynomial. For example, if we take a polynomial px, x square minus 3x minus 4, and find the value of this polynomial at x equal to minus 1, what we get? P of minus 1 is equal to 0. Similarly, p of 4 for this polynomial we get 0. As p of minus 1 is equal to 0 and p of 4 is equal to 0 for this polynomial, therefore minus 1 and 4, these are called zeros of this quadratic polynomial. Now, what do you mean the geometrical meaning of? There are some geometric meaning of the zeros of a polynomial. The linear polynomial ax plus b, where a is not equal to 0, has exactly 1 0, namely the x coordinate of the point where the graph y is equal to x plus b intersect at the x-axis. Okay. Linear polynomial has only 1 0, and that is the coordinate x coordinate of point where the line cut the x-axis. Similarly, the zeros of a quadratic polynomial ax square plus bx plus c, where a is not equal to 0, are the x coordinates of the points where the parabola, that means the graph of polynomial represented by this quadratic polynomial, intersect the x-axis. Here these two points we get where the x-axis cut the graph of this polynomial. Similarly, if we have a polynomial of degree n, that means the highest power of variable n, the graph of px intersects the x-axis at most n points. ज़्यादा ज़्यादा वो n points पे cut कर सकता है. Therefore, a polynomial of degree n has at most n zeros. For example, this is a graph of cubic polynomial and we get 3 intersecting point at x-axis. Okay. Now exercise 2.1. The graph of y is equal to px are given. For some polynomial, find the number of zeros. Here, this is the graph line which does not cut x-axis at any point. Therefore, we don't have any 0. That means we get no 0. Why? Because it line not cut at x-axis. Similarly, here, what we get? The graph cut at axis at one point, therefore we have 1 0. Similarly, here the graph cut 1, 2 and 3 points at x-axis, therefore we get 3 zeros. Similarly, in this 1 and 2 intersecting point at x-axis, therefore we get 2 zeros. Similarly, 1, 2, 3, 4 intersecting point at x-axis, we get 4 zeros. And in this we have 1, 2 and 3 intersecting point at x-axis, therefore this polynomial has 3 zeros. Clear? Now, relationship between zeros and the coefficient of a polynomial. First of all, what do you mean the coefficient of a polynomial? Coefficient, the real numbers which are the multiple of variables or constant. For example, we have a quadratic polynomial ax square plus bx plus c. Here a is the coefficient of x square, b is the coefficient of x and c is the constant term without x. Coefficient of x square a, coefficient of x b and the constant term c. Now, if these polynomials have two zeros, namely alpha and beta, these are Greek letters, then sum of 0, that means alpha plus beta is equal to minus b upon a. What is b? Coefficient of x, and a, coefficient of x square. Similarly, product of these 0, that means alpha into beta is equal to c upon a. What is c? Constant term divided by coefficient of x square. This you have to learn, sum of zeros and product of zeros. Now there is example based on it. Exercise example 2 from your book. Find the zeros of a quadratic polynomial x square plus 7x plus 10 and verify the relationship between the zeros and the coefficient. That means sum of zeros and product of zeros. So first we have to find the zeros for this polynomial, that you already know how we find. We studied in class 9th. This is a quadratic polynomial middle term splitting method. We get the factor x plus 2 and x plus 5 linear factors. So value of the 0, this polynomial is 0 when x plus 2 is equal to 0 or x plus 5 equal to 0. Therefore, x equal to minus 2 and x equal to minus 5 are the zeros of this polynomial. Now, sum of zeros, minus 2 plus minus 5, what we get? Minus 7. Minus 7 can be written as minus 7 upon 1. Minus 7 is the minus of coefficient of x. And 1 is the coefficient of x square. Here Therefore, it satisfies the first relation, minus coefficient of x minus b upon a. Similarly, product of zeros, minus 2 into minus 5, what we get? 10. 10 is the constant term and 1 is the coefficient of x square. In this method, we can verify the relationship between zeros and the coefficient. First, we have to find the zeros of polynomial by the factorization method and then simply verify the relationship. Now, if we have a sum and product of zeros of any quadratic polynomial, then we can find the polynomial, which is by the formula k into x square minus alpha plus beta into x plus alpha into beta. That means k is a real number, x square minus sum of zeros into x plus product of zeros. Example, find a quadratic polynomial whose sum and product of whose zeros are given minus 3 and 2. That means what we have, let alpha and beta are the zeros of this polynomial, then sum of 0, that means alpha plus beta equal to minus 3, product of zeros alpha into beta equal to 2. Therefore, the required quadratic polynomial k x square minus of minus 3x plus 2, that means k x square plus 3x plus 2. This is the required polynomial. We can use k equal to 1, which is real number. Therefore, polynomial will be x square plus 3x plus 2. Okay, this relationship is also for cubic. That means cubic. Therefore, what we have? We have 3 zeros maximum. At most 3 zeros can have a cubic polynomial. So let alpha, beta and gamma are the polynomial. Are the zeros of a cubic polynomial. Therefore, sum of zeros, that means alpha plus beta plus gamma is equal to minus b upon a. Sum of product of 2 taken 2 at a time, zeros is equal to c upon a, that means alpha into beta plus beta into gamma plus gamma into a is equal to gamma into alpha equal to c upon a, and product of all 3 zeros equal to minus d upon a. This is the relation between the coefficient and the zeros of a cubic polynomial.